Here we have the indefinite integral of the exponential function 7 to the 7x, and we want to find this indefinite integral. And so here we'll use the substitution method, and so we can let u be 7x, and so the derivative of u with respect to x will be 7. And so by definition of differential, this is du is equal to 7 times dx. And then now we'll make the substitution. So this becomes 7 to the u. Here we call u 7x. And then right here we have dx. And we need to write this in terms of du also. But here we only have dx, we don't have 7 dx. So what we can do here is multiply both sides by 1/7, by 1/7. And this becomes dx. And so now in the place of dx, we can have 1/7 du. And then 1/7 is the multiplication constant, so we can put it in front of the integral sign. The integral of a to the x is 1 over ln a times a to the x. And so here we will have 1 over ln 7, this is a to 7, and then times 7 to the u, and this will be 1 over ln 7, and then times u to the 7x, so it would be 7 to the 7x, and then plus c. And that's the answer. Here we have the indefinite integral of 7 of x squared times 4 to the 6x to the third. And so we want to find this indefinite integral. And so we use the substitution method. And so here we can let u be the exponent 6x to the third, and then we need the derivative of u with respect to x, so this is 6 times the derivative of x to the third. Derivative of x to the third is 6x squared, and so this will be 18x squared. And so by definition of differential, this is equal to 18x squared, and then times dx. And if we look back at our integral here, we don't have 18 x squared dx. We have x squared dx. So we only have x squared dx here. But here we have 18 x squared dx, and so what we can do is multiply both sides by 1/18, by 1 over 18. And this becomes x squared dx. So now this integral, this is 4 to the 6x to the third, but we call it u. And then x squared dx is 1/18 du. And then 1 over the 18 is the multiplication constant, so we can move it and place it in front of the integral sign. And so here we have the integral of a to the x is 1 over ln a times a to the x. And so here we have 4 to the u. So it would be 1 over ln 4 and then times 4 to the u. And so this becomes 1 over 18 ln 4. And then 4 to the u will be 4. U is 6x squared, so we have 6x to the third. And then plus c. And this is the answer. Here we have the indefinite integral of 4 to the x divided by 4 to the x minus 3. And we want to find this indefinite integral. And so again, we'll use the substitution method. So we'll let u be the denominator, 4 to the x minus 3. And so du dx, the derivative of a to the x is ln a times a to the x. So derivative of 4 to the x will be ln 4, and then times 4 to the x, and then minus 0. The derivative 3 is just 0, and so this equal to ln 4 . And so we have du is equal to ln 4 times 4 to the x times dx. And so our integral right here, we can rewrite this like this. This is 1, and then times 4 to the x. And then 4 to the x minus 3 is u. And then right here we have ln 4 times 4 to the x dx. But here we only have 4 to the x dx. So we can multiply both sides by 1 over ln 4. 1 over ln 4. And this would be 4 to the x times dx. So in the place of 4 to the x dx, we have 1 over ln 4 times du. And so this becomes 1 over the 1 over ln 4 is a constant, multiplication constant, so we can move it and place it in front of the integral sign. Antiderivative of 1 over u is ln x is ln u, ln the absolute value of u. So this will equal, and then u is, we call it 4x minus 3. 4 to the x minus 3. And then plus c. And this is the answer. Here we have the indefinite integral of 5 to the square root of x dividing by the square root of x, and we want to find the antiderivative. And so first, let's go ahead and rewrite this. And so this is the same as this. And then next, we'll let u be the exponent right here. So that's the square root of x. And this is x with the rational exponent of 1/2. And then we'll need to do du dx, since we're using the substitution method right here. The derivative of x to the 1/2, we'll use the power rule, and so it'll be 1/2 x. And so we place the 1/2 in front of the x, and then subtract 1 from the exponent. So a half minus 1 would be negative 1/2. And because this is the same as x to the negative 1/2, is the same as 1 over x to the 1/2. And then this is 2 over the square root of x. And so we have du is equal to this dx. And so now our integral, we need to write it in terms of u. The square root of x, that'll be 5 to the u. And then we have 1 over the square root of x dx, but here we have 1 over 2 square root of x. So here what we can do is multiply both sides by 2. And so this will become 2 divided by 2, which is 1. So we get 1 over the square root of x dx. And so now this becomes 2 du. And then the 2 is the multiplication constant. Then we can move it and place it in front of the integral. The integral of a to the x is 1 over ln a times a to the x. So the integral of 5 to the u would be 1 over ln 5. And then times 5 to the u. And so this becomes u is the square root of x. So in the place of u, we have the square root of x. And so the answer would be 2 over ln 5 times 5 to the square root of x, and plus c. And here we want to find the integral of 5 to the x plus 5 to the negative x squared. And so first, what we can do is go ahead and multiply this out. And so it will be 5 to the x times 5 to the x. And then 5 to the x times 5 to the negative x. And then now we have 5 to the negative x times 5 to the x. And then last, we have 5 to the negative x times 5 to the negative x. And recall that when we multiply two expressions with the same base, then we just add the exponents. So this is 5 to the 2x. And this is 5. This is x plus negative x is 0. This is negative x plus x, so it's 5 to the 0. And then this will make it 5 to the negative 2x. And so this is 1, 5 to the 0 is 1 and 1. And so we end up with 2 in the middle. And so now this integral becomes this. And then we just integrate each term separately. So let's do the integral of 5 to the 2x. Here we just use the substitution method. So we have let u be 2x. So du dx will be 2. So we have du is equal to 2 dx. And so this becomes 5 to the 2x right here. 2x is u. And then dx right here, we have to multiply both sides by 1/2. So we have 1/2 du. So multiply the left side by 1/2 and multiply the right hand side by 1/2. 1/2 times 2x is just going to be dx. And so in the place of dx, we have 1/2 du. And then 1/2 is the multiplication constant, so we can move it and place it in front of the integral sign. So this is 1/2. Antiderivative a to the x is 1 over ln a times a to the x. So for 5 to the u, it'd be 1 over ln 5, and then times 5 to the u. And u is 2x. So right here, we just put 2x. So this becomes 1 over 2 times ln 5. And then times 5 to the 2x. And similarly, if we do the negative for the integral of 5 to the negative 2x dx, the result will be similar. We just go through the steps. It will be negative and negative. And so now back to our integral. For the integral of 5 to the x, we'll get this. integral of the constant 2, that's just going to be 2x. And then the integral for phi to the negative 2x, we get negative 1 dividing by 2 ln phi. And then we need to plus c.